Well, I'm not going to start with the project. I'm going to start with giving you the exact information which I need, that you need to have in order to understand why corrosion is important. So the title is The Cost of Corrosion. And I'm going to, well, I don't need a lot of slides to convince you. Actually, I need 3 sentences. And I used that a couple of weeks ago with a representative of Exmar. Exmar is a large shipping company, one of the largest even in the world. It's a Flemish multinational. And first of all, I was there and we started to talk about corrosion. He said, yeah, but we have some problems, but maybe not. And I said, give me 3 lines. I gave him my 3 arguments and he was still not convinced. And then he started to give me a lot more anecdotes about why corrosion was apparently very important in this company. And at the end I could say, well, thank you, you proved my point. Well, so anyway, corrosion is not important. No, absolutely not at all, unless you recall this nice little ship. It's the Erika, who broke into 2 due to corrosion stresses, corrosion-related damage on the 12th of December 1999 in front of the coast of Brittany, one of the most important oil spills in Europe. It lost several thousands of tons of oil. Actually, nearly 20,000 tons of oil were spilled at that moment in the Atlantics. It's also not important because, well, you know, this is Bhopal, and a bit earlier. And even there, the explosion that we had in 1984 was due to a corrosion phenomenon. And if you say, yeah, but that's a long time ago, those 2 incidents, well, maybe you remember 2018, the summer, this bridge in Genoa in Italy marked the death of 43 people. Why? Because the steel cables were corroded. Now, of course, these are incidents, but these were already incidents with a major consequence, all due to corrosion. We tend to forget that. I don't really recall that a lot of people were really discussing corrosion in 2018 after this bridge collapsed. But let me put it in numbers. And now I'm going to give you these 3 arguments. First argument, corrosion costs every one of us, every country, on average, 3.8% of our gross domestic product. That is a study that came out. Well, there's a number of documents that came out, but the whole story was nicely recapitulated in the so-called impact study made by the North American corrosion engineers, NACE, 2016. If you just look for impact NACE, then you will find tables like this. And this came from another report, but it's in essence it's the same information. And what did they do? Well, first of all, it's very, very hard to compile data about corrosion. Why? Because no one measures it. So even you people that tend to work with steel and with water and with concrete, with steel inside and so on, I don't think that anyone has ever made specific calculations, specific estimates on how much corrosion is costing your company. If you have, please tell me. That's that questionnaire. So there are a number of more abstract methodologies. There are actually 2 major methodologies. I'm not going to details that, but so this is an overview of all possible corrosion studies over the last 50 years, and they always come up with, yeah, somewhere between, well, 5 to even 1% Japan. But that was a very big underestimate. On average, we spent about 3.8% of our gross national domestic product on corrosion. Let me just put that into numbers that are a bit closer to home. For Flanders, that means that corrosion cost us as an economy 8.4 billion euros every year. For the European Union, 531 billion euros a year. Did we measure that? No, it's an estimate, but that's probably a good estimate based on worldwide trends. And for those who want to know, yes, I used the Eurostat data. Of course, for 2019, 2020 is maybe distorting a bit. That was another co-row problem, but still, I think that 8.38 billion euros, if we could save that a little of that amount, it would really help us out a lot. That's the first thing, 3.8%. Second point, that's already an underestimation of the real costs, because it depends on sector to sector. There is probably not a big geographical distribution or change between difference between countries when we talk about this number, but there is a big difference between sectors. And the maritime sector, and that's of course the one that I'm closest to, coming from the Antwerp Maritime Academy, well, there we talk about nearly 20%. 20% of every euro we put into ship, port, offshore, everything that is steel and seawater, well, 20 cents of every euro goes to corrosion. Corrosion repairs, corrosion prevention, corrosion maintenance, corrosion inspections. And that's the one point. Second point is, and we're probably not taking into account possible indirect costs, like health problems, people that are in danger, people that get hurt because of corrosion, chemicals leaking away because of corrosion. That's why I gave you those catastrophic examples in the beginning. This is not taken into account when we talk about this 19.9%. That was my second idea. The third one is even more striking. If I can click here, yeah. Because again, international studies show that we can save money by changing the way we treat corrosion. And we can save 15 to 35% of that amount, which means for Flanders, we have a potential of saving between 1.25 and 3 billion euros every year. And for the EU, something between 80 and 186 billion euros a year. Given the fact again that Flanders, let's say, has a big maritime industry, even that could be higher. Why? Well, because we could cut, if we have a better strategy, then we're not going to maintain everything at the same high level all the time, but we could differentiate between when it's really important and when it's less important. We could save costs on maintenance. We could save costs on different inspections, or we can at least try to find other ways to inspect corrosion problems. One day, sending down a team of divers, one day that costs you 5,000 euros. I think, and maybe the people from C-Cube can give their idea, but I think that we can have inspection ways that will cost a lot less than 5,000 euros a day. Less problem means less production time that is lost, less product that is lost, less people that are hurt, less impact on your on the ecology, on the sustainability aspects of your enterprise. So which means that you get a greener image, and actually not just an image, but also a better green result. And that's, for example, interesting for ships. Your assets, your installations, your infrastructure will be there for a much longer time. So these are all possible ways to save money on corrosion. Ecological impact, well, even there, I mean, we all have to save carbon dioxide emissions. Well, here are a couple of numbers. You can do the math yourself for any for any specific application, but let's say that if you want to make a ton of steel, then you will emit nearly 2 tons of CO2. if just take into account that every 90 seconds, somewhere on the planet, 1 ton of steel is rusting away, which means 1 ton of steel, which means this is an added production that we need to organize of about 2 tons of CO2 every 90 seconds. Another estimate, about 50% of all the production of steel all around the world is not to create new things, it's to replace everything that has corroded. So maybe some parts are designed to stay there for a longer time, but the moment you see your ship, your installation, your tubes, your pipelines, and so on wasting away, well, this is your ecological footprint. So corrosion has an ecological footprint. Now, of course, I can give you facts and figures. We have also done that in the Socorro Project, and we're going to do it even at a much bigger extent. I can give you lots of figures about ships, about offshore. That's actually Jeroen's team. But I did a little work on corrosion losses in the drinking water sector. It's not very easy to find, but I found the white paper of the World Corrosion Organization, and I copied this nice graph out of there. These are, of course, three European Union and 1 other European country nowadays. And then we see that in the EU, we have up to 30% of all the drinking water that is being lost due to corrosion and due to other leakages, or maybe corrosion-related leakages. They were not very specific in that document. So 30%, maybe again, that's where we can save at least a little money and also a lot of product and be more sustainable. So if you want to read that study, it's you'll probably get we'll send you all the documents later, but it's the report here on the bottom. That's the white paper from the World Corrosion Organization. Now, why? Because it's not that we don't know how to do the technical work. We know a lot of stuff about sacrificial anodes, and we know about paint layers if we apply them correctly. We know about impressed currents. We know of different materials and so on. So actually, the technical body of evidence is rather big. But now I come to one of the bigger issues, and that has also been identified in this same NACE impact study. That is that, well, it's the whole strategy of how to deal with corrosion. It's which are the procedures we're going to follow. Where are we going to find the knowledge? Who is going to protect the knowledge within our organization? How are we going to select personnel on the basis of their knowledge? Do we have specific corrosion engineers? Do we have people that got extra training on corrosion? Maybe the people on the daily fields, the daily out there with all the equipment are well aware of their corrosion problems, are well vetted in this sector. But is the management aware of the problems? Are there plans? Are there specific objectives to deal with corrosion? I have to say, I talked with a couple of the bigger ports in Flanders and the Netherlands. Let's be as non-specific as we can be. And in 2 cases, I got the answer, we don't know. There are no specific guidelines. When something is broken, we repair it. Do we have people with specific knowledge? Yeah, maybe there are a couple. Is that an aim of the company? Not at all. And actually, I'll come to that later on. We have been spreading our questionnaire, and you have again seen it. There's not a lot of people that can give us any answer on what their procedures are. And again, we have a whole methodology to assess that, and so far we can't even use it because we don't get any answers, because people don't know what to say. And that's not your personal responsibility, because you're probably also not on the very top of your company, but maybe it's something we need to work together to bring that up with every possible company. So anyway, let's say in the end of 2018, that's -2 BC, before COVID, we got together with a couple of Flemish partners first, and then we got some English and French people on board, and we founded what we now know as the Socorro Project. And Socorro stands for Seeking Out Corrosion, Corro, with the added subtitle Before It Is Too Late. The idea of the project is simple. So, well, the idea is simple, the execution is not. Let's try not to measure corrosion after the fact. Let's try to come up with a measure of corrosion and the risks it entails for your installation before the corrosion can even start. Let's try to find out if you are going to construct your installation, your port, if your ship will be in contact with that type of seawater or fresh water or so on. Let's make sure that before that we can already estimate the corrosion risk you are going to be exposed to. This we got funded by the Utrecht 2Cs program, one of the last ever. It's with the British, so you know what happens with collaboration with British people. Sorry, I shouldn't have put. I will show you all the logos of all the partners in a minute, and it will still go on until March 2023. You also see the date when it started, so you know that we had not one but two Corro problems. This is the whole concept. So we are going to we know that there is a relation between parameters like pH, temperature, salinity, oxygen, redox potential, and so on, and the rate of corrosion. So we are going to measure all these things and a lot more. And that's mainly the job of Jeroen, who is heading up the people in the first work package, is we're going to try to come up with a software package based on artificial intelligence that will turn these sensor readings into a corrosion rate and then a corrosion risk model. So we are going to, before the fact, we want to establish possible risk of corrosion. Of course, is it a bad or is it a good location? That's the really simplified way, but okay, we have numbers. Then we are going to demonstrate that algorithm. If that algorithm is ready and the prototype is nearly ready, or the prototype is ready and we're poised to install it all over Flanders and England and the Netherlands, these are the locations that were foreseen to put what we call a demonstrator. So that's one, an offshore installation. That's the blue accelerator. That's a sensor pylon in front of Ostend at 1 kilometer. We will have a couple in industrial waters. There will be one at BASF and one at a water purification plant. It's maybe not Aquafin, but okay, that's still. There will be two actually. That's for the University of Leuven to work on. We will put something on commercial ships. We'll have two. We're planning to have 2 or 3 on board of an Exmar ship, and one in a specific location in Zelzate. We will have different ports: Vlissingen, Ostend, Endurance, that's Hoek, Den Helder, sorry, not Hoek, Den Helder, the Netherlands. We have 2 British ports, Shoreham and Newhaven, ports on the south coast near Brighton. And then we also have the Victorian Pleasure Pier of Southend-on-Sea. Look that up. It's a 2-kilometer pier that extends itself into the Thames estuary, and we will put up sensors there as well. And so these sensors are going to collect both the physical-chemical conditions temperature, oxygen, and so on. And they're also going to collect data about the corrosion rates. And it will teach us a lot about how, first of all, what are proper ways to install long-term corrosion sensors in real conditions. And secondly, they will help us to refine our algorithm. That's the whole plan. When we have all these data, well, at the moment we already have a couple of people working on devising life cycle analyses and life cycle cost analysis, so that we can come up with, okay, these are possibilities for your installation. So let's see what will be the cheapest or the ecologically soundest way to protect your installation against corrosion. That's the plan. There's one parameter that we still haven't got under control, and I heard yesterday that it may also be a problem for several installations in the drinking water sector. So I have to mention it. That is microbially induced corrosion. And we got already one location where it ran out of hand. That's these are yachts that were attacked by bacteria. And these are images of, well, not even a year of exposure. And this is a pitting corrosion on the hull of a yacht of about 4 millimeters in less than a year. Yeah, so anyway, that's what we want to deal with. Of course, one, and that's, I will be coming back to it every time, because we really need a lot of information also from companies that deal with corrosion every time. So we have this questionnaire. You go to our website, there's the link to a Google form. That's our industry survey. At the moment, I checked yesterday afternoon, we had actually one serious response, and even there, we noticed that a lot of the questions are really difficult, apparently. So please have another look at it, spread it out, spread the word, because this, and especially part 2, so the first part is, who are you? And if you don't want to tell us, then at least tell us in what sector you work. That's why we know it's one of you, because a drinking water company. But the second part is a series of multiple choice questions where we ask you specifically how you deal with corrosion. That's actually why I introduced this triangle. That's what we want to know. How are the companies in Western Europe, or let's say Flanders, England, France, and so on, how good are they dealing with corrosion on a company level? And at this moment, actually, and we had big discussions with the Interreg people, because they don't believe us. Maybe now they do, but they didn't believe us. They thought everyone had a great corrosion plan. And when we said no, we know it's not going to be the case. They said, no, you have to prove that. So please help us prove it. Fill it in and say we don't know on every question. And you will even help us then. If you have data, the data are even more welcome, of course. The third part of the corrosion is the corrosion questionnaire. There we're going to ask you for numbers. And we always thought that was going to be the hard part. How much money do you spend on corrosion? How much, and so on. So that's the main idea of our questionnaire. Right, and just to top it off for the time being, these are all the partners. So you see, we have a couple of, we have a big number of very important, big experts in the corrosion field and otherwise, and we would really spread out all this expertise and deal with corrosion questions from your side. Thank you. That's all for me for now.